DICOM is an official Gen4 example demonstrating the usage of DICOM medical images in Gen4 simulation. It relies on a third-party library, DCMTK, to read DICOM images. It is very easy on Mac to install the latest DCMTK library using Homebrew. However, I failed to compile the example due to an error related to DCMTK. I accidentally triggered the AI agent of my terminal while I was trying to solve the problem by myself. The debugging procedure proposed by AI seemed very reasonable to me. I decided to give it a try and see if AI can help me solve the compilation error. The terminal I'm using is called Warp. It brings AI to our daily command line usage. I feel like that I am an experienced command line user and don't normally enable the AI agent in Warp. However, Warp without an AI agent is already very useful. For example, it can predict what kind of command I'd like to run. This significantly accelerates my efficiency in the command line. Coming back to this specific issue, I failed to compile Gen4 example DICOM due to an error related to a third-party library, DCMTK. I had no prior knowledge on DCMTK and didn't know how to solve this problem exactly. AI's approach was very reasonable. It started with checking if I installed multiple versions of DCMTK, and then started to search for the class name shown in the error message in DCMTK header files. Failed to find that, AI tried to search for the string case insensitively. Failed to find anything again. AI realized that there was no header files in that folder, so it started to search for header files in general and found that there are subdirectories in the include DCMTK folder. AI chose to check a folder called DCMRT because it contains the string RT in it. That was a very good guess that I might not be able to do by myself. In this subfolder, AI indeed found a header file that started with the string we are looking for. In this header file, AI found the declaration of the class that caused the error. It immediately realized that the DICOM Gen4 example used the wrong header files, drtbl2.h, instead of the correct one, drtbl1.h. Found the cause, AI directly fixed the error in the Gen4 example source code and tried to compile it again and failed again. At this point, AI just repeated its way of fixing these errors, that is, searching for the right header files in the DCMTK folder, and found that drtrbs3.h instead of drtrbs8.h needs to be included. After fixing that problem, the compilation still failed. More fixing still failed in compilation. And then it found a different issue. This time, a function cannot be found anywhere in the DCMTK headers. It proposed to get rid of that piece of code completely. I was hesitating to do that, because fixing wrong headers is one thing. Getting rid of a block of code is another. What if this action causes more error? But after checking the code, I realized that it only tried to print out some information on screen. It is not critical. A bit of Google search tells me that in 2019, that specific function was removed from DCMTK. While a post in the Gen4 users forum this summer showed that someone had the same issue of headers when they used the same updated DCMTK version, and the same issue with that specific function. There was no solution provided in the Jiangfor forum. At this point, I was convinced that the AI solution was in the right direction, so I agreed to comment out the code block. But the make command still failed. However, AI noticed that this time all compilation errors are gone. The new error was a linking issue instead of a compilation error. By running make in the verbose mode, AI found that the linker tried to link the library OFSTD but was not given the location of it. Its solution is very straightforward. Tell CMake the location of these libraries through some CMake variables, and the problem was solved instantly. Since I did not know the existence of these CMake flags, I wouldn't be able to find this solution by myself. That's not all. AI also provided a nice summary of all the issues and solutions at the end, and also provide the correct CMake configuration for the compilation process. I found that the DCMTK DRR didn't have to be set because it will be set to something else automatically by CMake. After the compilation, I saw the DICOM executable in the build folder. Ran it, and a CT image showed up in my Jiangfor GUI. To summarize, AI Assistant in command line is surprisingly helpful even for experienced users. It does not only provide solutions but also demonstrates the process of identifying problems. Human intervention is useful to verify the sanity of AI solutions, and the combination of human and AI is very powerful.